Hello friends, in today's video we are going to control the speed of this DC motor using this joystick. So as long as the joystick remains at its center position, the speed is 0, and if I move the joystick backward, you can see the speed start to increase. And if I move the joystick forward, the speed again start to increase but in opposite direction. But the twist comes when I switch the power supply of the joystick from Arduino to breadboard. And you can see that joystick is at its center position but the motor is still rotating. Instead it should not rotate. So let's uncover the reason why this is happening. Now let me give you a brief about the circuit diagram. So I am making use of only one direction pin on the joystick. So this VRX pin is connected to the analog pin A0 of the Arduino. And I am connecting the enable pin of the motor driver, which is this brown wire here, to the PWM supported pin on the Arduino, which is pin number 9. Because this enable pin is used to control the speed of the DC motor, that is why it must be connected to the PWM supported pin only. And there are two more pins also, in 1 and in 2, which are for the direction control, either anti-clockwise or clockwise. So these are also connected to the digital pin, and rest all other wiring are for the power supply. Now there are two ways to power this joystick. Either you can power the joystick from the external supply, like these two wires will be connected to the battery, or you can power the joystick from the Arduino. Now there are difference. So there is a significant difference between both the methods of powering this joystick module, either from Arduino or from external supply. And you need to know that this joystick outputs only voltage, maximum voltage at this position and 0 voltage at this position. Similarly, in the other direction, maximum voltage at this position and 0 voltage at this position. And I have already discussed about the details of the joystick and its proper working in my previous video. You can check out from the item. So the Arduino converts the voltage of this joystick into analog values from 0 to 1023. Because Arduino is a 8-bit microcontroller, so the maximum analog value it can read is 1023. Now what is really happening behind the scenes? So first of all I will discuss about these two points, and then I will discuss what are these. So how Arduino actually reads the voltage levels. So you see the Arduino ADC range is from 0 to V reference. Here ADC means analog to digital conversion. So V reference is 5 volt by default, so the range would be from 0 to 5 volt. And the analog to digital conversion is done like this. 0 analog value is mapped to 0 volt, 512 is mapped to 2.5 volt, and similarly 1023, which is the maximum analog value, is mapped to 5 volt. Okay, and when you power the joystick module from the Arduino, what happens? The joystick voltage at this position, which is 5 volt here, and the joystick reading at the center is 2.5 volt and 0 at this position. So the ratio would be half, because 2.5 divided by 5 is half. So this will be mapped to 512, because here the voltage is 2.5 volt. Okay, so we will be getting value 512 at the center position. So what happens when we power the joystick from external supply? So the joystick voltage and the Arduino ADC reference are no longer perfectly aligned, they mismatch, and because of this mismatch we do not get the value of 512 at the center. We get deviation from it, either less than it or greater than it. In fact, the entire range would get disturbed. Like on powering from Arduino, we get 0 voltage at this position, 2.5 here and 5 voltage here. But on powering from external supply, it is also possible that we may not get 0 voltage or 5 voltage in the entire range, right? So here is an example. Suppose the joystick voltage at the maximum position is 4.6 volt and at the center we get 2.3 volt. So the ratio would be 2.3 divided by 5 into 1023, because the ADC reference always remain equal to 5 volt because it is default. Okay, so we will be getting 468, which is less than 512, and this is the reason why the motor was still rotating when the joystick was at center position, because this value is less than 512. But the intended behavior of the DC motor should be like this: it should stop when the value at the center is 512. So here is a program of the project. The enable pin of the motor driver is connected to pin number 9 on the Arduino, which is a PWM supported pin, and both the direction pins of the motor driver are connected to the digital pins 6 and 7, and joystick pin is connected to pin number A0. So we are going to use only one direction of the joystick, and you can see the joystick value and the motor speed both are initialized to 0. And in the setup section, all the pins of the motor driver are defined as the output mode, and we are initially stopping the motor. You can see there is a low signal on both the direction pins. And in the loop section, we are reading the analog state of the joystick pin. Okay, and if the joystick value is greater than 500, actually the value of the joystick at center is 512, so we are keeping a buffer of 8 here, value 8. Okay, 520 minus 512, which is 8. So if the joystick value is greater than 520, we are mapping the joystick value from this range to this range, 0 to 255, which is a PWM range. Okay, and we are rotating the motor in one direction. And in this line, we are writing the motor speed on the enable pin A. Similarly, if the joystick value is less than 505, so here also we are taking a buffer of value 7. So we are rotating the motor in other direction. And if the joystick is at the center, then we are stopping the motor in both the directions, and speed is 0. So if you learned something new from this project, hit the subscribe button so that you never miss my latest video tutorials, and also suggest me some add-ons in the comment section, and I will see you with the new project in another video. Till then, goodbye.